Hello, favorite students, and welcome to Solving Force Problems with Mr. Peacock. Today we're going to be going over example number 1 on page 32 in your red workbook. We're on the Forces workbook, page 32. It's a problem about an elevator. Anytime we are solving force problems, we're going to start with these steps. So first, I'm going to draw a system schema and a free body diagram. Then I'm going to write out my Newton's second law equation. The net force equals the mass times the acceleration. Then I'm going to break up my net force into its parts by adding all of the positive and subtracting all of the negative forces. Then I'm going to plug in my acceleration, and last I'm going to solve. And I'm going to solve with variables first and put in my numbers last. So in this problem, we have a student riding in an elevator. You can see my system schema here. I've got the earth, the elevator floor, the person, and the rope. You'll notice that the only things touching the person are the gravitational force and the normal force. So when I draw my free body diagram, I should have the normal force from the floor pushing up and the gravitational force from the earth pulling down. And in this problem, we know it's going at a constant velocity, so we know that these forces have to be balanced or equal to each other because of Newton's first law. So we have done step 1, we drew the system schema and the free body diagram. Next, we're going to write out our Newton's second law equation. Because we're moving in the y-axis, this elevator is moving up and down, we're going to do our net force in the y direction equals mass times acceleration in the y direction. So we're being specific about our axis. So we write out that equation. Check. Next, we're going to break up our net force. You'll notice this whole time I have my equal signs coming down, and I'm going to keep all of my mass times acceleration on the right side, all of my forces on the left side until we get to the end. So this net force breaks up into normal force going up, that's a positive, so I add it, and gravitational force, Fg, going down, it's negative, so I subtract it. Those two together make up our net force. So we take net force out, we put normal minus gravity in. All of that equals mass times acceleration in the y direction. So we've done step number 3. Step number 4 is we need to plug in acceleration. We know from this problem that it says we are going at a constant velocity. That means our acceleration equals 0. So we're going to plug in a 0 for acceleration. Check. Now we're going to solve. So we have normal force, and remember our gravity equation, or our equation for weight, is, let me write it over here, Fg equals m little g, the mass in kilograms times little g. So we take that Fg out, we substitute in mg. Then we have normal force minus mg equals 0, because mass multiplied by 0 gives us 0. I can then add mg to the other side. I get normal force equals mg, and now I do my numbers last. I plug in 85 for m, 10 for g, and that tells me that the normal force is equal to 850 newtons in this case. So in the next video, we'll talk about what happens when we're no longer going at a constant velocity, but those are our 5 basic steps for solving force problems. Be the leaders that your community needs and deserves, choose to be great, and have a great day.